Since the early 1960s and the birth of the environmental movement, two issues have been of enormous concern to Americans: the quality of the environment and the effects of the environment on our health. The first of these, environmental quality, is primarily an ecological concern. We seek to preserve natural beauty and the natural balance among all living things. But in this program, we're going to delve into the second issue, the effects of the environment upon our health. That concern is primarily about synthetic or man-made chemicals. They are, for some, the most disturbing of all our worries about the environment. Camo Phobia, the fear of chemicals, along with it, dread of cancer and birth defects. The fear is understandable. Traces of synthetic chemicals seem to be everywhere. More and more toxic substances are being detected in the air and the water, the soil, even the food we eat. As surprising as it may seem, there is increasing evidence that the presence of trace amounts of chemicals in the environment pose no threat to human health. It all boils down to what one scientist called big fears, little risks. In this report, we're going to examine the evidence behind that statement. We'll find out some answers as to what is really causing most of the cancer in this country and what we can do to improve our chances for long life and good health. In the process, we'll meet some of the world's leading experts on cancer, chemistry, and the effects of chemicals on the human body. Each of these scientists has achieved a reputation for excellence over a lifetime of scientific work. The first is Dr. Bruce Ames, chairman of the Department of Biochemistry, University of California at Berkeley. He created the Ames test, a screening method widely used to identify substances that cause cancer. His field is biochemistry, the study of chemistry in living organisms.
We've done a big database of taking all the animal cancer tests in the world, put the information into a computer, and calculated potency of the carcinogens. In our database, there were 303 chemicals that were tested in both rats and mice. 58% of these are positive. So again, people are saying carcinogens are rare. They're not rare.
The carcinogens Ames is talking about are substances that cause cancer in laboratory rats and mice. Based on these animal tests, Ames reports an enormous number of carcinogens occur naturally in many plants and foods.
Because plants make natural toxic chemicals to keep off the insects. So every plant has a mixture of 30 or 40 chemicals that they've devised in evolution to kill off insects and predators and fungi. Plants don't have teeth, they don't have immune systems, and they can't run away, so they fight back by chemical warfare. For example, mushrooms have carcinogens, but should we really worry about eating an occasional raw mushroom? So that gets to, do we want to worry about low doses of carcinogens? And I think probably not. And in any case, man-made pollution is really tiny, very tiny, compared to the background of natural substances. If you're really concerned about tiny doses of carcinogens, which I'm not, one would look at these natural things first.
Ames and his colleagues first published their study in Science magazine. It was entitled Ranking Possible Carcinogenic Hazards. The article states that we are exposed daily to a multitude of natural and synthetic chemicals which, at high doses, cause cancer in animals. However, they have no known effect on human health. Research using animals is slow and very expensive, costing as much as $500,000 per experiment. But the results of these tests must be interpreted with caution. A mouse is not a little man. While animal testing is critically important for biomedical research, Ames doubts the value of studies with rats and mice at high doses in predicting human cancer in the general population. The Ames test, which exposes bacteria to chemical substances, is faster and much less expensive. If the bacteria mutate or change their cell structure, it indicates that the substance could cause cancer. These substances are called mutagens. Back in the early 1970s, when the Ames test was first being used, a flame retardant called tris, used as a protective substance in children's clothing, was found to cause cell mutation. Ames became very concerned at this discovery and was instrumental in getting the substance banned. Since then, however, with the growing scientific awareness that our natural and synthetic environment abounds in trace levels of mutagens and carcinogens, Ames has reached just the opposite conclusion. He now believes that tris and other minute quantities of chemicals pose no hazard to health.
People have been using our test and other tests for 15 years or so now. What have they learned? Are they getting a different message than animal cancer tests? And I think the answer is yes, they're getting a very different message than animal cancer tests. Because it's so cheap to test things. In animal cancer tests, only maybe 100 chemicals are tested a year, 100 or 200 in the whole world because it's so expensive. And so where mutagenicity tests, there are 3,000 laboratories doing our test, for example, and they're testing everything from cups of coffee to outside of hamburgers, and they're finding mutagens everywhere. Okay, so that gets one shaken up a little bit. Well, does that mean the world is full of mutagens? And the answer is yes, the world is full of mutagens.
Having identified carcinogens and mutagens by means of the Ames test and animal studies, we're indeed finding them everywhere. This is not because there are suddenly huge amounts of natural and man-made poisons being added to the environment. Instead, it has to do with vast improvements in our capabilities to detect and measure tiny amounts of matter. This capability to find carcinogens and mutagens where none were believed to exist has indeed grown by leaps and bounds over the past 30 years. As a result, science is pushing back the limits of zero to the vanishing point. In 1950, the best that a good analytical chemist could do was detect 1 part per million. Any level below that was considered a zero, not detectable. 15 years later, by 1965, analytical chemists were able to identify substances at 1 part per billion. 1 part per billion is equal to 1 second in 32 years. Or as Ames puts it, it's 16 inches between here and the moon. Zero now became any concentration below this level. Only 10 years later, by 1975, chemists were able to detect substances at levels of 1 part per trillion with methods that are 1,000,000 times more sensitive than in 1950. Zero had practically disappeared. Today, some substances can be measured at 1 part per quadrillion, and it's safe to predict that detection levels eventually will be brought down to parts per quintillion. Substances that we now think are not present will be detected. The mere fact that they can be detected, however, does not pose a hazard. Zero is retreating to the vanishing point. In analytical chemistry, there may no longer be any such thing as zero. Take this glass of water, for instance. Over a decade ago, Dr. William Donaldson of the Environmental Protection Agency wrote a paper about what could be found in a single sample of water. He said, more than 2 million organic compounds have been identified. Our improving analytical abilities eventually will enable us to find all the chemicals known to man in a common glass of drinking water. Well, if this is so, does the mere presence of a chemical compound pose a problem? If we follow the idea that no amount of a chemical must be found in our water, we face a task that is clearly impossible. To achieve absolute zero, we would have to destroy all the matter in the universe. Since we can't entirely eliminate chemicals, even those which in high dose cause cancer in animals, we must now focus on assessing the risk to our health. Just how risky are these tiny trace amounts that science can